Assalamualaikum warahmatullahi wabarakatuh. My name is Aisyah binti Karanwa. I'm from Sanyo. So in this video, I will talk about job sheet 6, which is about delta and star electrical connection. For this lab, our main tool were the simulating software to look our circuit diagram. So we also use various electrical components like resistor and measurement tools to get our current and voltage readings. We put the circuit virtually to simulate how they behave. So let's talk about the two main way we connect three phase power, which is delta and star. For delta connection, we can think of a triangle. Each phase is connected end to end, forming a closed loop. So in our lab, we saw that in a balanced delta connection, the line voltage is equal to the phase voltage. So in our table 1, show that line voltage of 102.8 volt, which are also the phase voltage, and the line current is typically higher than the phase current in a delta setup. This connection is good for transmitting high power and for motors. And other than that, for star connection, we can imagine a Y shape or 3 point meeting at a one center point called the natural. So in our lab, here the line voltage is square root 3 times the phase voltage. So in our phase voltage was around 59.36 volt. Then our line voltage would be 59.36 times square root 3, and it's equal to 102.8 volt. So this match what we measure for line voltage in delta part. For the line current is equal to the phase current in a balanced star connection. This connection is great for getting both line and phase voltage, and is low for a natural wire, which is useful for lighting and household loads. So we also look at balanced and unbalanced load. So for balanced loads, this is when the resistor is the same across all three phases. In table 1, results show this with all line current and phase current being the same, which is 6.596 milliampere. This is ideal for smooth operation and efficient power delivery. So for unbalanced load, this happens when the resistance is different for each phase. So in task 1, unbalanced load section in table 2, we specifically set different resistance. For R1, we set up 9k ohms, and for R2, we set up for 18k ohms, and then for R3 is 9k ohms. So our result in table 2 clearly show the current are different for each phase, which is for I1 is 6.596 milliampere, and for I2 is 3.298 milliampere, and for I3 is 6.596 milliampere. So this difference in current indicates an unbalanced loads, which can cause issues like overheating and inefficiency in real system. So for a key insight from this lab was really saying how the connection type, which is delta or star, directly affect the relationship between line and phase voltage and current, and also how important it is for a three-phase system to be balanced for optimal performance. One challenge was carefully setting up the simulating diagram, because it's a bit slow to move the component, and ensuring all the measurement blocks were correctly placed to get accurate readings. But by double checking our setup and be patient, we are able to get consistent results that show the aspect relationship. This lab greatly improved my understanding of delta and star connection and the importance of balanced load in three-phase power system. So that's all from me. Thank you.